We are recording at 6 frames per second. Is that good? Yes? 8 frames per second. Okay. So, we are doing inverse functions. At the end of this lesson, you will be able to, 1, find inverse functions informally and verify that two functions are the inverses of one another. 2, use graphs of functions to determine whether they have an inverse. 3, determine if functions are one-to-one. And 4, find inverse functions algebraically. Okay, so today we're pretty much going to cover learning target number 1, which seems like we are not halfway through the lesson by the end of the day today, but trust me, this is the big thing. All these are consequences of this. So tomorrow will go much faster. But this one will take pretty much the day. So let's talk about functions, because that's what we've been talking about all year. First of all, let's say I got a function called f of x, and f of x equals x plus 4. And I am limiting my domain and range to this. I asked you first, in a little bit of review, what is the domain of f of x? So Henry's got it, but inside voice. You're good. You're good. Don't worry about it. Who knows what the domain is? Show of hands. Lay it on me, Logan.
1 equals to x equals to 4.
I'm sorry? I couldn't hear you. I'm sorry.
1 equals to x.
So 1 less than or equal to x. Like that. Flip it. So one thing here, first of all, I do have sets that look like this, but can x be can x be greater than 1 and greater than 4 at the same time? Yeah, how would I write that? Greater than 1. Because if it's this, it's also going to be this, right? If it's just this, is it also going to be this? No. So, all right. But this domain is very specific. Okay? There is only a small domain and range to this. The domain of this function is 1, 2, 3, 4. Because the whole function covers these 4 ordered pairs. So when x is 1, y equals what, Jet? Say with confidence. Thank you. Good. And when x is 2, Violet, what is y? 6. And Riley, when x is 3? 7. And then Dawson, when x is 4, y is 8. Okay, so if this is the domain, the range is going to be what? Right now. Ken, what's my range going to be? So is 5.5 in my range? No. So I have to list my range discretely. I have to list my range discretely. What does that mean? That means I have discrete parts in my range. I don't have a range of stuff, right? I don't have anything between 5 and 8. I gotta say 5, 6, 7, 8. There's a difference, right? 5, comma 6, comma 7, comma 8. Okay? So that's my domain range. Now, if this is f, f is defined as this. It takes 1 and makes it a 5, takes 2, makes it a 6, takes 3, makes it a 7, takes 4, makes it an 8. The inverse of f undoes this. It takes the range and sends it back to the domain. It takes the range of f and sends it back to the domain of f. But the range of f is not the range of the inverse of f. The range of f, another name for the range of f, is the domain of the inverse. Because remember, the inverse works on 5, 6, 7, and 8 and sends it back to 1, 2, 3, and 4. Okay? So, let's draw a picture, because that can be a lot to digest. If I have this blue circle, which I've called the domain of f, right? And I got some x in there, right? I take a function called f, and I send it to that dot there. That is also, that's called f of x, right? I want to look at the inverse of this function. It takes stuff out of the range, so it works on f of x and sends it back here. This is f minus 1, which is how I write the inverse of f. Okay? So, now that we've gone through an example, gone through a picture, let me know when you're done writing that picture. That's an important picture to write. That gives you a visual idea as to what an inverse function is. Okay? The next slide I'm going to show you is not something that you can copy verbatim, but it is something that you should understand and be able to regurgitate in your own words. Okay. May I? I heard one not yet. I'll give you 15 seconds. No pressure. No pressure at all. It's down to 5. Got it, Lincoln? My man. All right. Now, let's go to here. Okay, the definition of inverse functions. If f and g are two functions such that f composed with g of x for all x's in the domain of g, and g composed with f of x equals x for all x's in the domain of f, then g is the inverse of f, and f is the inverse of g. And we annotate this like so. So g is the inverse of f. G is the inverse of f, and f is the inverse of g. Okay? What is this down here? Oh, yes. And this is the important part. The inverse of the function applied on x is equal to x. And the inverse composed with the function of g of x is also equal to x. So if I take a function, or if I take x, and I do g to it, and then I do the inverse of g to it, what do I always get? I get what I started out with. I get x. If I take y and I do g to it, and then I do the inverse of g to it, I get y. Whatever I start out with, if I take 7 and I do g to it, and then I do the inverse of g to it, I get 7. If I do pickles, do g to it, and then do the inverse of g to it, what do I get? Pickles. Good. I'll throw this out. All right. Clear as mud? Good. All right. Let's inform. I hate this term. I hate the informally. I think it's sloppy language. All right. What they mean by informally is just kind of figure it out in your head. That's what they mean by informal. But the book goes with it, so I'm going to go with it. All right? I have faith in the book, even though I don't like it. All right. So it says, find the inverse function for f of x. And f of x in this case is 4x. Then once we found the inverse to f, then I want to verify that both f composed with the inverse of f and the inverse of f composed with f are both equal to the identity function. And what's the identity function? I'm going to use g of x so I don't get confused, but equals x. That's the identity function. That is the identity function. Okay? So first, let's think about f of x. It's saying I want to start with x, and then I want to multiply it by 4. How do I undo multiplying x by 4? I take 4x and then divide it by 4, and I get back x. So f of x, f inverse f of x equals x divided by 4. So that's what they mean by kind of figuring it out in your head, right? Then it says verify that this and this are both equal to the identity function. Let's start with this. So we're going to say f of f to the minus 1 of x. I want to see what that equals. So what is f to the minus 1 of x? I want to know what that is. What is that, Violet? What I just underlined? What is that? It's up here, right? F to the minus 1 of x is this guy, right? So what I do is say, oh, that is this. So I'm going to put this where I got that. So it's f of, and I'm using the substitution property of equality and replacing the inverse of f. I'm replacing it with x over 4 because the two are equal, right? This is equal to this, therefore I can replace this with this. You see my logic there? I don't like that all the way. Okay. So now I take f and apply it on x over 4, which means what? Well, f of x tells me that if I got x, I take x and multiply it by 4. But now I'm not working on x. I'm working on something called x divided by 4. So what do I do to x divided by 4, Kai? What did I do to x? What did I do to x up here? Tell me, what is that doing to x? You're looking for a more complicated answer, and there is none. Tell me what you've learned the last 3 years. It's taking x and doing what to it? No, what's this? It's multiplying it by 4, right? We know that, right? Just read it. We're not looking for any greater truth other than unpacking what we already know. We are taking x and we're multiplying it by 4. And I don't mean to try to embarrass you, because this is difficult stuff. Okay? No, it is. But now, I'm not concerned about doing f to x. I'm doing f to something called x divided by 4. So, I want to do f to this. What do I need to do to this guy? I need to do this. I need to take x divided by 4. Well, f tells me to take whatever's in the parentheses and multiply it by 4. Well, I got x divided by 4 in parentheses. So I take that and multiply it by 4. Do we get what that function notation means?
Yep.
That's what the function notation means. I take whatever's in the parentheses. F tells me, hey, these are the instructions to do the x. Okay, but I don't have x anymore. I got x divided by 4. But I still do f to it. And f says, multiply whatever's in parentheses here by 4. So that's what I'm doing. I'm like a dog. Sit. And then you give me a treat. Alright? Well now, can I simplify this? Simplify. 4 times x over 4. What happens? Boom, boom. 4's go away. And I'm left with x, which is the identity function, yes? Okay, so we've done the one thing. Now we got to go backwards. We got to do the same thing going the other way. So I got to do f to the negative 1. Hey, listen up. I'll have this video posted at the end of the day, okay, Tyson? Okay. I'm doing the inverse of f, and I'm applying it to f of x. So this is the inverse composed with f of x. What do I hope to get? I want to get x again, right? Well, first, I need to know what f of x is. What is f of x? It's 4x. So I replace f of x with 4x. And then the inverse of f was this guy right here, right? So now, I take whatever's in the parentheses, and I take it and I divide it by 4. What do I got in parentheses down here, Logan? I got 4x, exactly. So I take 4x, and I do what to it, Dawson? What do I do to the stuff in parentheses? I divide by 4. Right. I am doing exactly what I am told. I'm not reading into it. I am just reading the directions that are written on paper or on smartboard, and I'm doing exactly that. Nothing else. No more, no less. And then once I've done this, I can do what, Will? Simplify. Thank you very much. Boom, 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 and I get x. So, does this meet the definition of an inverse function? Yes, it does. Yes, it does. Okay, now, I want you guys to do an informal invert. Find the inverse to this informally, meaning think about it in your head. Once you've done that, put your pencil down. You got one already? So write it down and then put your pencil down. That way I know you figured it out, or at least have an idea of what you think it is. So write down f of x, and then tell me, written down paper, what you think the inverse to f of x is. If I get the x, I Okay, so it's taking x and it's subtracting 6. Right? So, inverse of that, does that? That's 6. And so if I take that out, then I get the inverse of that. That's 0. I start with x, right? I do that. Then I take the inverse of that. I take away 6 and I add 6 again. Wow. Yeah, which in this case is x. I go to family stuff and all that. Once you've done the inverse, who got the inverse of x equals x plus 6? Who got? Okay, good. You get it? Okay, now I want you to verify that f composed with the inverse of f is x, and then I want you to confirm that the inverse of f composed with f is also the inverse. Only then do I know that what? Not about you, about this. The royal you. What do I know about these guys? Once I found that both compositions give me the identity function. Thank you. They are inverses. That's what we want to confirm. So do that. Do f composed with the inverse of f, and then do the inverse of f composed with f. Composed functions. This is review, and it is topical to this section as well. Now what do you do with x plus 6? So take x plus 6, and then minus 6. Now do it backwards, so the opposite way. Oh! So, you got a function that takes x, right? And that subtracts 6 from it, right? And I want to find a function that turns out x. Yeah, so let's put 0 in there, right? And I take away 6, I get what? -6. Now, let's stick with your negative x. Now, you take that -6, and you plug it in for this x. So negative, or the opposite of -6 is what? Plus 6 is, and I don't get 0. Right. Now let's do this. Let's do that. So now I take 0, subtract 6 from it. You get -6, right? And I take that -6 and I put it back in here. So now I get -6 plus 6. I get what? 0. See how we use that? Just gotta make sure that we make it sign. Yeah, you're canceling out one term. This isn't the equation as much as it is a list of instructions. Right? Okay. Now, let's do do f applied to the inverse of x. So x composed with the inverse of x, or the inverse of f. Check. I'm going to work from the inside out, right?
Yeah.
What do I replace in the parentheses? Why? No, the inverse is...
Okay.
So what do I put in the parentheses? X plus 6. There you go. All right? Now, remember, they're like a puppy that wants to please their master. We're just doing what we're told. I know it's a terrible analogy, isn't it? It's the best one I can come up with, though. Anyhow, now I take x plus 6, and I do what to it? I do f to it, right? So here it says, well, if I got x, I put it here, and I take 6 away from it. Well, I don't have x anymore. I got something called x plus 6. And what do I do to it? Well, I take x plus 6, and I do what to it? Subtract 6. Now I simplify, and I get what? This is the notation. We are straight manipulating the notation. We are doing exactly what the notation tells us to do. My man. All right? Now, do the opposite. Do the backwards. I got f to the negative 1. So the inverse of f composed with f. What is f of x? I wonder quietly to myself. Oh! It's x minus 6. So what do I replace? What do I put in there? Good, Bonnie. X minus 6. And then I take x minus 6, and I do the inverse of f to it. And what does that tell you to do, Kristen? Add 6. Add 6 to what, Alex? Add 6 to what? What's that? For the microphone. X minus 6. Okay. So I'll take an x minus 6 and I'm adding 6 to it. And then I simplify. And that means I can crossies, right? Equal that. Okay? Ignore all this garbage. Ignore that hot garbage. Let's move on to this. Let's move on to this. When does my class end here? Oh, good. All right. So here's what we got. I got a for instance here. I got f of x equals 5 divided by the quantity x minus 2. I want to know, and I want you guys to see if you can figure this out on your own, so everybody work on their own paper. Is g of x the inverse of f? Or is h of x the inverse of f? Which one? I want you, how would you do this? It's for sure one of those two. I can guarantee you it is one of those two. How would you test g of x? How would you test g of x to see if it's an inverse of f? Yeah. To g of x? Yeah. How do we say that? F composed with g. What's the other thing I need to make sure happens? If let's say I do this and it is x. I have to do the opposite, right? G composed with f of x. Now what if I do this and it's not x? Do I have to do this? No. He's just picking on you right now. Man, that is brutal. And then do the same thing with 8.
And all we're doing now in this function is composing your bill.
See how the vocabulary helps us, though?
Yeah.
It really helps us. The vocab helps us. Has anybody not handed their quiz in yet?
I did great on this.
Yeah, he handed it in when he was supposed to hand it in. Did you?
Yeah. Yeah, I did.
No, you didn't. I know you didn't.
Oh, I forgot that. I didn't know you had handed enough for this.
How many times did I say that on Wednesday? I said, on a, you know, there's a rule of public speaking called the rule of eights. Eights. No, not eight. Not eights. Not eights. Eights.
Oh, yeah.
The rule of eights. So what the rule of eights is in public speaking is when I say something to a group, I can guarantee beyond a shadow of a doubt that 1/8 of y'all heard me. That's all I can guarantee. I might get better, but I won't get worse. Okay? Even if I'm a terrible public speaker, which I'd say Mason thinks I'm a terrible public speaker right now. He's not feeling me right now. You okay, bud? All right. But, am I embarrassing you? Anyhow, if I say something, even if I'm a terrible public speaker, I can guarantee that 1/8 of you heard me. So, what's 1/8 of 16? So 16, out of 16, 2 heard me, which leaves me with 14 without the message yet, right? So if I say it again, no. So now what's 8 of 14? It's just less than 2, right? We'll round up and say it's. We'll round up and say I got 2, right? Right? So now 2 more people heard me, and now I'm down to 12. And what's 1/8 of 12? 1.5. Let's round down. So now I'm down to 11. Now that's 1, 2, 3. Oh. 3, I said 3 times, and I've gotten not quite half the class. The 4th time I say it, right? Now, do I ever get down to 0? No. So what this tells you, it's like TV, right? Where you get the same commercial hundreds of times. It works on the same principle. That's why you get the same commercial over and over and over again. When you hit the play a video so I can get my free lollipop or whatever, Candy Crush or whatever stupid game we're playing this week, then you get, I just got that video, right? Who's that happen to? Right? And then you want another lollipop, so you hit the play video. You know, I just got that one. Right? That's what it's doing. It's leveraging this. It's trying to get in front of as many people as possible because it knows it only got 1/8 of it. So now, let's do, now that we've gotten that tangent out of the way, let's do F composed with G of X. F composed with G. What is G of X?
X minus 2 over 5.
X minus 2 over 5. So what do I put? Here?
X minus 2 over 5. X minus 2 over 5.
Yes. Because this guy is that guy, which equals that guy, so I can put that guy there. X minus 2 over 5. Now, I got X minus 2 over 5, and I do what to it? I do F to it. Oh, that is G. No, I help it. Alright? Well, what is doing F do to it? Well, F takes X, right? And it takes 2 away from it and then divides 5 by whatever I get.
Yeah.
Right? So where do I not put? So now I got 5 over 5 over. Right, okay. So here's what I'm going to do. Check this out.
Over a lot.
X minus 2 over 5. So this goes right here. Do we see where we got that from? Whatever I got it in here, I put there. Well, here I got x minus 2 over 5 in there. And so that goes right here. Okay? Now what do I do? Simplify. You had it right the first time, Dawson. All right. How do I simplify this, though? Why can't you can't? This is 4th grade stuff. This is 4th grade stuff. Let's break it down. Listen up. Right here. Can we do that? Can we simplify that?
That's what you're going to tell us.
You should know how to do this. You also know how to do that. Can I add this to this? Not yet. What do I need first? What's going to be the common denominator? 5. Okay. So which one? Is this on 5? That has a 5. That has a 5 in the denominator, right? There it is. Does this have 5 in the denominator? So what do I need to multiply as 5? I need to multiply by 1, but that 1 looks like this. Right? And that gives me what? I'm going to write the whole thing down now. X minus 2 over 5 minus 10 over 5. Now can I simplify this? Alright, I can simplify the denominator now. Equals 5 over x minus 2 minus 10 is over 5. Now I got a number divided by a fraction. How do I do that? How do I do that? Thank you, Dawson. I'm going to myself. You don't say the exact right thing by taking a guess. That is not a thing. So I multiply by the reciprocal of the denominator, which is this. Which equals, what does this give me? 25 over x minus 12. Can I simplify any more? I'm kind of done, aren't I? So is this the inverse?
No, it is not.
It is not.
That
That is not the inverse because I don't get the identity function. So I'm done. I'm done. Do I need to do this? Do I need to do this? Not only no, but no. Right? Alright. I can't say it, otherwise you guys will get me fired. How do I make this? Man. I'm trying to highlight this stuff to make it small, but here's what I'm going to do instead. I'm going to say, alright, so now we need to test this function, right? So now we're going to do h composed with f of x. Henry, what is f of x?
5 over x minus 2.
So this is h of 5 over x minus 2. I just replaced f of x with what I know f of x to be. F of x is 5 over x minus 2, so I replace it. Now, I take 5 over x minus 2 and I do h to it. And what does h tell me to do? Whatever is in the parentheses, I divide 5 by it, and then I add 2.
Yes.
H tells me to do what to x? Take x. Divide 5 by that x. And add 2. Well, what am I working with here? Am I working with x? I'm working with something called 5 over x minus 2. I take that, and I divide 5 by it. Yes? And then I take whatever that is, that whole thing, and I add 2 to it.
Cross off the 2 by it, and get X.
Well, first things first. What do I do first? Yeah, I can say I don't want that, don't want that, don't want that. But let me ask you this. Let's do a quick poll since I got the time. How many of you all thought at the outset? How many of you all thought at the outset that g of x was my inverse function?
Yeah.
If you were a bet man, would you have said g of x at the outset?
Oh, yeah.
No.
Yeah.
All right. Now the smart money's on h, right? Especially since Will got me to say definitely one of these is the inverse. But we need to simplify this first. What do I do first? Jeff, what do I do first? Divide? Okay. How do I do that? How do I do this guy? I like it. 5 over 1 times x minus 2 over 5. Now, before I multiply this, simplify, cross cancel, right? Get rid of those things. Oh, I can't forget this though. I can't forget that.
X minus 2 plus 2.
Oh, I get it.
X minus over plus 2 equals, no. All right, that is h composed with f composed with x. Guess what I'm going to have you guys do right now? F composed with h composed with x. Do f composed with h composed with x.
What's the thing for
F composed with h composed with x. F composed with h composed of x. That's what I want you to do right here. I want to finish this slide today. I'll finish this slide today. I have not posted a video or the practice set for this section to the Google Classroom yet. That will be done by the end of the day. You can believe that. Yes, sir. So, F composed with h of x. And then h is 5 over x plus 2. Okay, so, now what's F? F is, well, let me ask you this. Where is, okay, so, here's what I would do. Instead of having to look up and down again, F of x equals 5 over x minus 2, right? H of x equals 5 over x plus 2, right? You put h in there, right? Now, you gotta do x, I'm sorry, you gotta do f to this guy, right? So, start with, so show me what, you just have the light put on my side, so show me.
Wait a second.
Oh my God, it works. Whoa! No way. So you got 5 over x plus 2. You got to put 5 over x plus 2. You have to look at the x. So it's 5 over x. So you got 5 over this whole thing, right? But in place of this, you gotta put this whole thing in. Yeah, that's a good way to put it. But instead of having extra, you got, that thing goes in there, right? Yeah, 5 over x plus 2. Right? That was what we had as x, right? That's what's in the question here, right? And then we're going to have to do it in the numbers, so now,
He's doing it right.
I got one here, but do I need it? And you know, each of us equals divided by this side. I don't like doing this with a slanted direction bar, because you don't know which way. 5 over x minus 2, or there be 5 over x minus 2. Those are drastically different expressions, right? I do the horizontal expression. But now let's unpack it. Inside out, right? So then it's F of
I'm pretty sure my,
now, my that's so much fun. Oh, yeah, going to the
Now we're all doing the same thing.
Ladies and gentlemen, thank you for a good afternoon.